My name is Peter Ilsley. I'm the rover integration lead for MSL during the assembly test and launch operations phase, or ATLO. The tests we're doing now are actually helping us learn how to drive the arm from both the operator side as well as the flight software side, helping us develop that rover hand-eye coordination. Let's say we wanted to go drill a rock. The way we do that as humans is actually we use our depth perception and we look at that rock in space and we say, oh, we think it's about so far away. Well, that judgment has come through our human experience as we've learned exactly how far away our arms are from things. The rover needs to do the same thing, but right now it's not very good at predicting that. It certainly is one of the most complicated things we do with the rover, simply because of the number of degrees of freedom of the arm, the number of motions the arm can make. The arm can actually collide with the rover. The arm can actually hurt the rover if we're not careful. Just like you can poke yourself in the eye, we can do the same with the rover. So we have to teach it not to do that by defining a space it keeps out of. In the next test sequence, we're going to actually lift the rover onto a tilt table and tilt it up to 20 degrees, and that's where we'll actually simulate being on a crater wall or a large slope or a large obstacle, so that we will understand how that change in gravity vector will actually affect that same set of arm movements. I actually think this is one of the most rewarding times in the build process. This is really where you get to see all of those neat firsts of the rover, the first drive, the first motions of the arm with the flight system software and with the rest of the flight system hooked up to it. And seeing that successfully work is incredibly rewarding. I'm Peter Ilsley, and this has been your Building Curiosity Update.